Hello everyone, welcome to Technogate. I am the physics faculty in Technogate. Myself Jagan. I have 10 years experience to teach MSET, NEET and Mains. Today I am going to discuss about atoms. It's a secondary topic. This atom is a very important chapter. In MSET there is one question will come, in Mains also one question will come. One question is equal to the 4 marks in Mains. So atoms. Right. In atoms, we'll discuss about, there are 4 topics are there. Out of 4 to 5 topics are there. Out of 5 topics, there are 3 topics are very important. So one by one write. First topic is Dalton's theory. Dalton's theory. Dalton's theory is not much that important. Next one is Thomson atomic model. Thomson atomic model. Thomson atomic model. Thomson atomic model. Right. Next thing is Rutherford alpha scattering. Rutherford model or Rutherford alpha scattering. Rutherford model. We'll discuss all these things one by one clearly. Next thing is Bose atomic model. Bose atomic model. In this Bose atomic model, there is one subtopic is there, that is hydrogen spectrum. Hydrogen spectrum. These are the topics we are going to discuss in this atoms chapter. So Dalton's theory, that much of important, and here Rutherford model is very important, and Bose atomic model and hydrogen spectrum also very important. Okay. So what is Dalton's theory? Dalton is a scientist name. So what he say that about the atoms, and what is Thomson atomic model, and what are the demerits and merits, what are the failures of the Thomson atomic model. Then we are going to discuss about Rutherford model. What are the merits and demerits, what are the failures, what are the success in the Rutherford atomic model. Then finally Bose atomic model. So first one is Dalton's theory. Dalton's theory. Just one statement is there. As per Dalton, material contains small elementary particles or small elementary atoms. So this is one of the material. It contains so many number of elementary particles or so many number of elementary atoms. It has given by this statement has given by the Dalton. Then after this Dalton, Thomson model. Thomson model. Thomson atomic model. So what is the Thomson atomic model? So as per Thomson, there are positive charges are there and negative charges also there. So here there is this is the Thomson atomic model. Thomson atomic model. As per Thomson, there is a positive charges are there and negative charges are there in atoms. Then, but these positive charges are distributed, or total mass, the positive charges and mass of the atom are distributed uniformly over the atom. Right? It is not concentrated in a particular point. But this total atom mass and total positive charge is distributed throughout the atom. This is the total atom. So here, so we can say that this is the positive charge. Positive charge. This total is positive charge. In this positive charges, right? These electrons are embedded. Electrons are there in throughout the atom. So like a watermelon model. In watermelon, there is a total positive charge will be, form in watermelon, in water form will be distributed over the watermelon, but seeds are embedded. Seeds are there. Seeds are maybe oka place lo untayi. Right. So seeds are there throughout the watermelon. Like this, here electrons are there throughout the atoms. And this positive charge and mass of the total atom is distributed over the total atom. So simple. Total mass and positive charge is uniformly distributed over the atom, but in that electrons are there in a particular positions throughout the atom. So what is the merits and what are the theories it has explained? So it has explained the thermionic emission. So what is thermionic emission? And next one is photoelectric emission. Next one is ionization. These are the three theories, thermionic emission, photoelectric emission, ionization. These three theories are explained by the Thomson atomic model. So we need not discuss all these things. What is thermionic emission, what is photoelectric emission, and ionization. Right? So then next is what are the demerits? Demerits are failures. There are some topics where it does not explain. So that is hydrogen spectra. It's a very important hydrogen spectra. This Thomson atomic model is unable to explain the hydrogen spectra. So this is about the Thomson atomic model. So simple Thomson atomic model. Total positive charge and mass are uniformly distributed throughout the atom, and electrons are embedded. So in a particular positions throughout the atom. It explains thermionic emission, photoelectric emission, and ionization, and it does not explain the hydrogen spectra. Right? So this is about the Thomson atomic model. Next. After this Thomson atomic model, so there is another model which is explained by the Rutherford. Right? So he explained the stability of the atom. Rutherford explained the stability of the atom. So and how the electrons are embedded, or how the electrons are rotating, revolving around the nucleus. Right? So everything he has explained. That is called Rutherford atomic model. Rutherford atomic model, or we can say it is a Rutherford alpha scattering. Rutherford atomic model or Rutherford alpha scattering. So what is Rutherford atomic model? So per Rutherford, he has given one statement. As per Rutherford, electrons or total nucleus positive charges, total positive charge and total mass of the atom is concentrated at a center, at a particular point, that is called center, and total negative charges, all the electrons are revolving around the nucleus. So once again, total positive charge and total mass of the atom is concentrated at the center, that is called nucleus, and all the electrons are negative charges revolving around the nucleus, right? So this is nucleus. It is a positive charge. Positive charge is a nucleus, right? Around this nucleus, around the nucleus, electrons are revolving. Electrons are revolving. Electrons are revolving a circular orbit, right? So how he has given statement? What is the he has done one experiment that is called, that is a famous experiment, Rutherford alpha scattering, right? So to prove his statement, as per his statement, total mass and positive charge is positive charge of atoms is concentrated at a particular point. It is called nucleus. It is called nucleus. And all negative charges and electrons are revolving around the nucleus, right? So this statement has proven by the Rutherford alpha scattering. So what is Rutherford alpha scattering? It's a very important and Rutherford alpha scattering. Rutherford alpha scattering. So this is a experimental phenomena. Rutherford alpha scattering. Rutherford alpha scattering. It's one of the experiment. Just now I given one statement. Total mass, total mass of the atom and positively charged particles and total mass of the atom is concentrated at the center of the nucleus or at the center, and all the electrons are revolving around the nucleus. One more statement he has given, that is total atom is empty. Total atom is empty. So total mass is concentrated at a particular volume and remaining atom space is empty. That is here total mass is concentrated at this position only, right? So this is totally empty, right? So అంటే దీని వాల్యూమ్ ఆటమ్ యొక్క మాస్ అండ్ వాల్యూమ్ మొత్తం కూడా మ్యాక్సిమం ఈ మాస్ మొత్తం కూడా ఈ రీజియన్ లోనే, ఈ న్యూక్లియస్ లోనే కాన్సన్ట్రేట్ అవుతుందని చెప్పండి. ఈ స్పేస్ మొత్తం కూడా empty. So but here there are some electrons, small mass electrons or negatively charged electrons rotating in a particular orbit such. So to prove this statement, he has done one experiment that is called Rutherford alpha scattering. As for this Rutherford alpha scattering, right? Rutherford alpha scattering, right? This is one of the experimental phenomena. Here, if you observe that, here there is one arrangement is there, that is called lead bags. Here there is a source, polonium source. We can say it is a polonium source or radioactive element. It will come in the nucleus chapter. There is a source is there, that is called polonium source. Around this polonium source there is a lead box is there. So from polonium source there is a radiation will come. That is, there are some elementary particles will come. That is alpha particles. from this polonium, alpha particles will come here. Alpha particle means alpha particle. We can write this alpha particle is equal to 2He4. 2He4. That means it has atomic number is 2 and mass number is 4. So this is the helium atom, is nothing but a alpha particle. Now, like this alpha particles will come from the polonium. There is a arrangement is there. This is the lead screen, because due to this lead screen, alpha, whatever the alpha particles emitted from the polonium, it does not deviate. It does not deviate. Right? Deviate avukunda straight line ivote alpha particles. Ikkada manaki polonium ఉన్నది, రైట్. ఇక్కడ నుంచి మనకి ఆల్ఫా పార్టికల్స్ వస్తున్నాయి. ఆల్ఫా పార్టికల్స్ ఈ లెడ్ స్క్రీన్ వల్ల ఏంటంటే ఇట్ డస్ నాట్ డీవియేట్ అవ్వకుండా అన్ని ఆల్ఫా పార్టికల్స్ ఆల్ ది ఆల్ఫా పార్టికల్స్ రైట్ కమ్ టువర్డ్స్ like this. And another arrangement is there. This is screen, gold foil screen, which is made up of the coat, that is coating, gold foil screen. We can call it as a gold foil screen. Right. Here there is a gold foil screen. Right. Gold, which is a very thin. And now, and another arrangement is there. So around this gold foil screen, so it's a screen is there. Here it is a screen. Around this gold foil there is screen, which is made up of with zinc sulfate. Right. Behind this zinc sulfate screen, you can call it as a screen. Right. There is one microscope is there. Microscope. Right. So this is the arrangement. So what are the things here? There is a polonium source is there, which emits the alpha particle, and there is a lead screen is there, which does not deviate the alpha particle, which controls the deviation of the alpha particle, and there is a screen, gold foil screen is there. So, and behind this gold foil layer is there, right? Behind this gold foil layer there is a screen is there, that is zinc sulfate screen is there, and the last one is here microscope is there. So why we have to do this experiment? Because to prove total mass and positively charged particles are concentrated in the nucleus, right? Remaining part of the atom total should be empty, and all the electrons are revolving around the nucleus. To prove this one, we have to do this experiment, right? So now right now here this is polonium, lead, and it's a gold foil screen. It is a screen, and here there is a microscope. It's a microscope. Zinc sulfate screen, gold foil. It's a very thin. It's a polonium. From here, alpha particles come here. There are so many number of alpha particles come. Right? So many number of alpha particles come. So here, like this, alpha particles come here. Most of the alpha particles, 99% of the alpha particles which is coming from the polonium, right, is undeviated. That means So whenever it touches the screen, alpha particles are touches the screen, then after touching the screen, right, it's undeviated. The path of the alpha particles does not change. Away అనేది చేంజ్ అవ్వదు, రైట్. ఎందుకని చేంజ్ అవ్వదు, రైట్. సో 90, suppose 100 alpha particles are coming from the polonium, then 98 alpha particles అనేవి దాని పాత్ డివైడ్ కాకుండా డైరెక్ట్గా వెళ్ళిపోతుంది. ఓన్లీ 2 to 3% ఆఫ్ ఆల్ఫా పార్టికల్స్ ది పాత్ ఇస్ డివేటెడ్. యాంగిల్ దాని పాత్ అనేది చేంజ్ అవుతుంది. సో ఎప్పుడైతే మనకి ఇక్కడికి వచ్చేసి దీంతో ఆల్ఫా గోల్డ్ కాయిల్తో టచ్ చేసిందో, ఆల్ఫా పార్టికల్ టచ్ చేసిన తర్వాత కొన్ని పార్టికల్స్ దాని పాత్ అనేది డివైడ్ అవుతుంది, రైట్. కొన్ని పార్టికల్స్ ఏమిటంటే ఇట్ కమ్ బ్యాక్, కంప్లీట్గా వెనక్కి వచ్చేస్తాయి, రైట్. కొన్ని పార్టికల్స్ ఏమిటంటే ఇట్లా కంప్లీట్గా వెనక్కి వచ్చేస్తాయి, రైట్. సో ఏదైతే మనకి ఇక్కడ డివైడ్ అయిందో ఆ యాంగిల్ ఏమిటంటే we can call it as a angle, scattering angle. We can call it a scattering angle, right. So now some of the particles come back into the same opposite direction. So ఆ యాంగిల్ ఏంటంటే 180 degrees. అట్లా వెళ్తానే మళ్ళీ వెనక్కి వస్తుంది ఇక్కడ. So it's a 1% of the alpha particles come back. That is 180 degrees, right. So here ఆల్ఫా పార్టికల్స్ అనేవి ఇక్కడ నుంచి వస్తున్నాయి, వచ్చేసి గోల్డ్ పాయింట్ టచ్ అయిన తర్వాత స్కాటరింగ్ అవుతాయి. స్కాటరింగ్ అయిపోయి కొన్ని ఆల్ఫా పార్టికల్ 99% ఆఫ్ ఆల్ఫా పార్టికల్స్ అనేవి ద పాత్ ఆఫ్ ది ఆల్ఫా పార్టికల్స్ డస్ నాట్ డీవియేటెడ్, చేంజ్ చేసుకోవు. బట్ కొన్ని పార్టికల్స్ మాత్రం డివైడ్ అవుతాయి. మరి ఎందుకని డివైడ్ అవుతాయి? వై ఇట్స్ డివైడెడ్? కొన్ని పార్టికల్స్ వెనక్కి వస్తాయి. వై దీస్ పార్టికల్స్ ఆర్ కమ్ బ్యాక్ and why this some of the particles are deviated? Why this some of the alpha particles are undeviated? There is a reason, is it? Right. So that is no, because so whenever alpha particle touches the, so gold foil is which is made up of with the gold atoms, that is layer. So we have taken one gold atom. So this is the gold atom. So around this gold atom electrons are revolving. ఎలక్ట్రాన్స్ అనేవి ఇది చుట్టూ రొటేట్ అవుతాయి. ఇక్కడ న్యూక్లియస్ ఉంది అనుకున్నాం, గోల్డ్ న్యూక్లియస్. సో గోల్డ్ న్యూక్లియస్ జడి, రైట్. నౌ ఇక్కడ గోల్డ్ ఫాయిల్ మీద గోల్డ్ న్యూక్లియస్ ఉంది. ఒక న్యూక్లియస్ ఒక ఆటమ్ తీసుకుని ఐఎమ్ డూయింగ్ ఇన్వెస్టిగేషన్. హియర్ ఆల్ఫా పార్టికల్ ఉందన్న, ఆల్ఫా పార్టికల్ విచ్ ఈస్ emit from the polonium, which has a more energy, which has a more speed, energetic alpha particles come from the polonium. So ఇవి ఈ డైరెక్షన్ వస్తున్నాయి విత్ స్పీడ్ ఆఫ్ m, more energetic, రైట్. ఈ కొంత స్పీడ్ వస్తుంది, వచ్చేసిన తర్వాత రైట్. సో వచ్చిన తర్వాత ఏమవుతుందంటే ఆల్ఫా పార్టికల్స్ అంటే సింగిల్ ఆల్ఫా పార్టికల్స్ డజంట్ కమ్. సో దేర్ ఆర్ సో మెనీ నెంబర్ ఆఫ్ ఆల్ఫా పార్టికల్స్ కమ్ హియర్. There are so many number of alpha particles come. So it was right. So ఇవన్నీ కూడా ఆల్ఫా పార్టికల్స్. ఈ ఆల్ఫా పార్టికల్ ఆల్రెడీ చెప్పాను, ఆల్ఫా పార్టికల్ హ్యాస్ 2He4, right. So here there is center of the gold coil and it has some particular energy. Now these alpha particles come towards the nucleus. Whenever these alpha particles come towards the nucleus, which it has some particular right atomic number, and it has some particular it has a positive charge, right. So this positive charge is repulsed the alpha particle with some particular energy, right. సో ఈ డైరెక్షన్ లో ఇక్కడ ఆల్ఫా పార్టికల్ వస్తుంది ఇక్కడ, రైట్. దీన్ని ఈ న్యూక్లియస్ అనేది ఏం చేస్తుంటే రిపల్ positive nature, it is also positive nature. Right? Ripple చేసినట్టు ఏంటంటే the deviation of the alpha particles is changes. ఒకవేళ if it is more energetic, so the alpha particles will reverse direction, will move reverse direction. ఇట్లా వస్తుంది alpha particles, ఇది more energetic అనుకోండి, ఏమవుతుందంటే repulsive force వల్ల it will go back, right? So it will go back like this, right? What is the angle here? Theta is equal to 180 degrees, right? దేనికి ఇప్పుడు ఇక్కడ వచ్చే అంటే ఈ న్యూక్లియస్ దగ్గరలో ఉన్న ఆల్ఫా పార్టికల్ రేంజ్ లో ఉన్న ఆల్ఫా పార్టికల్స్ అనేవి మనకి రివర్స్ డైరెక్షన్ లో వచ్చేస్తే ద యాంగిల్ ఎంత 180 degrees scattered angle. Now what about this angle, this one? So this will also come here with some energy. This is ఈ న్యూక్లియస్ ఏం చేస్తుంది, రిపెల్ చేస్తుంది, right? But it will not come back, right? So the path of the alpha particle is changes, deviate అవుతుంది. Here also this is also deviated. Actually ఈ direction వెళ్ళాలి, it has to move in this direction, but the path of the alpha particle is changes. So this is the scattering angle, you can call it Z. Here scattering angle is 180 degrees. This is the scattering angle. Here also actual path ఇది, but ఇది 180 degrees angle తో scatter అవుతుంది, కొంత angle తో scatter అవుతుంది, right? What about this one? So here it does not deviated. Why it is not deviated? Because nothing is here. Electrons are there, but electrons doesn't have that much of capability. It has a small mass and small electron system. So alpha particle has a more energetic. So due to this energetic alpha particle, so this alpha particle does not deviate, right? Here also these alpha particles are does not deviated. So only alpha particles are deviated due to the nucleus, which is in a particular small volume. If whatever the alpha particles touches in the range of this small volume, it is those alpha particles are deviated. ఏవైతే alpha particles ఈ రేంజ్ లో ఉన్నాయో alpha particles మటుకే deviate అవుతాయి. So out of this nucleus, these alpha particles are does not deviate, right? So why these alpha particles does not deviate means here nothing is there, it is empty space. This is totally empty space. So that's why this total atom is empty. Only total positive charge and mass of the nucleus is concentrated at this position only. He has given statement. Rutherford has given statement. Total nucleus is total mass and positive charge is concentrated at this statement only, this position only, center. Because here alpha particles are deviated. Here there is no deviation because nothing is here. Electrons are there, but which has a less energy. Like this, he has proven. Now, how many number of alpha particles are scattered or deviated? First, we have to find out how many number of alpha particles are scattered or deviated, right? That is called scattering. Right. Here so many number of alpha particles are coming. Alpha particles. Here there is no deviation. Here some deviation is there. Here also some deviation is there. Here more deviation. It come back. If you observe, the alpha particles which is come close to the nucleus, which has a deviated more. The alpha particles which is away from the nucleus which దూరంగా ఉంటే అవి డివైడ్ అవ్వట్లేదు. న్యూక్లియస్ నుంచి దగ్గరకు వస్తే అవి ఏమైతే డివైడ్ అవుతున్నాయి. రైట్, ఎన్ని ఆల్ఫా పార్టికల్స్ అనేవి డివైడ్ అవుతాయి? హౌ మెనీ నెంబర్ ఆఫ్ ఆల్ఫా పార్టికల్స్ ఆర్ deviated? So that is one formula is that number of alpha particles scattered, we can call it as a scattered. Number of alpha particles are scattered. That formula is alpha particle scattered n theta is equal to, it's a important formula, n theta is equal to n naught. N naught means initial number of alpha particles, n naught into n into t, n naught into n into n into t into z square e power 4, z square e power 4 by 8 pi epsilon naught whole square into r square into e square into sin power 4 theta by 2. This is the formula. So for what this formula? How many number of alpha particles are deviated whenever it touches the gold foil? How many number of alpha particles are deviated? That is n theta. Here n naught is initial number of alpha particle. Initial number of alpha particle. Now another one is T. T is thickness. T is thickness of the gold foil. Here once again I will write here n theta is equal to n naught into n into t into z square e power 4 by 8 pi epsilon naught whole square into r square into e square into sin power 4 theta by 2. Here just now here I drawn diagram. This is polonium, here lead, this is a gold foil, here alpha particles come here. So this is a screen, it's a microscope. Right? Here initial n naught means initial number of alpha particles. Initial number of alpha particles. Whatever the alpha particles coming from the polonium is nothing but initial number of alpha particles. Now n is number of gold atoms, in gold foil in small volume. That means the meaning ఏంటంటే ఇది గోల్డ్ ఫాయిల్ కదా. సో ఈ గోల్డ్ ఫాయిల్ సో ఒక పర్టికులర్ వాల్యూమ్ తీసుకుంటే ఎన్నైతే నెంబర్ ఆఫ్ గోల్డ్ ఫాయిల్ ఆటమ్స్ ఉంటాయో దాన్ని ఏమంటే స్మాల్ అంతా ఇండికేట్ చేస్తాం. నౌ నెక్స్ట్ వన్ ఇస్ టీ. టీ ఇస్ thickness of the gold foil. Thickness of gold foil. Thickness of gold foil. Another one is Z is the atomic number. So atomic number for helium atom is 2 He4 అని చెప్పాను. And atomic number for gold atom is 59. So that is atomic number. E is the charge of the electron, and E, capital E, it's a very important. Capital E is energy, kinetic energy. So kinetic energy of particles. It's important. Now is kinetic energy of alpha particle. Here theta is the scattering angle. Whenever the alpha particles comes towards the gold foil, it is deviated. So whatever the deviation, whatever the deviation is called, that is called scattering angle. So this is the formula for number of alpha particles are scattered. Once again, n theta is equal to n naught. N naught is nothing but a number of alpha particles in a initial cell, which is coming from the polonium. N is the number of gold foil atoms in a particular volume. T is the thickness of the gold foil. Z is the atomic number of gold foil and atomic number of the alpha particle or helium. Next, E is the kinetic energy of the alpha particle. Theta is the scattering angle. So what is R? R is nothing but a distance between the screen. This is the screen and gold foil. This is the R. From this formula, we can say that we say that n theta, number of alpha particles, it's an important formula. N theta is directly proportional to the T. The meaning in gold foil thickness ఎక్కువ ఉంటే number of alpha particles scatter అనేవి కూడా ఎక్కువ ఉంటాయి, right? And one more thing is n theta is directly proportional to the z square, and n theta is inversely proportional to the E square, where E is nothing but a kinetic energy, that is E is equal to half mv square. E is equal to half mv square, right? N theta is inversely proportional to E square. దీని మీనింగ్ ఏంటంటే ఆల్ఫా పార్టికల్ ఎనర్జీ ఎక్కువ ఉన్నప్పుడు, if alpha particle energy is more, then number of scattered alpha particles are less. అంటే ఇక్కడ న్యూక్లియస్ ఉంది, ఇక్కడ ఆల్ఫా పార్టికల్ ఉంది. ఆల్ఫా పార్టికల్ ఎక్కువ ఎనర్జీతో వచ్చింది అనుకోండి, సో ఇట్ విల్ గో స్ట్రైట్ లైన్, ఇట్ విల్ నాట్ డీవియేటెడ్. సో number of energy is more, energy of the alpha particle is more, then number of alpha particles scattering are less. One more relation is that E is equal to 1 by 2 mv square. 1 by 2 is constant, m is constant. Then if you substitute n theta is inversely proportional to E square. That means 1 by 2 mv square whole square. That is called, that means v power 4. If you substitute E value here, 1 by 2 mv square whole square, 1 by 4 m square v power 4. 1 by 2 and m square is constant, so n theta is inversely proportional to the v power 4. So v is the speed of the alpha particle. If speed is more, number of alpha particles deviation are less. And one more formula is there. That is, this is also very important. N theta is inversely proportional to the sin power 4 theta by 2. N theta is inversely proportional to the sin power 4 theta by 2. That means this is one of the relation, and we can write this relation like this also. N theta is directly proportional to the cosecant power 4 theta by 2. Right. So from this you can write like this. దీని నుంచి మనం n1 by n2 is equal to, if you compare, మనం కంపేర్ చేస్తే వేరే ఆటమ్స్ తో కూడా కంపేర్ చేస్తే, రైట్. సో n1 by n2 is equal to sin power 4 theta 2 by 2 by sin power 4 theta 1 by 2. So this is the some basic formulas about the number of particles are scattered. So once again, number of particles scattered, n theta is equal to n naught number of into n into t into z square e power 4 by 8 pi epsilon whole square into r square e square sin power 4 theta by 2. Now n theta is the number directly proportional to t, n theta is directly proportional to z square, n theta is inversely proportional to the e square, n theta is inversely proportional to the e square, where e is the kinetic energy. If kinetic energy of the alpha particle is more, then number of deviation of the alpha particles are less. N theta is inversely proportional to the 1 by v square, v power 4. And one more formula, n theta is inversely proportional to the sin power 4 theta by 2, and we can write like this also, cosecant power 4 theta by 2, and n1 by n2 is equal to it's inversely proportional, that's why sin power 4 theta 2 by 2 by sin power 4 theta 1 by 2. So we'll do some 5 to 6 problems about this formulas, right? This is about the Rutherford atomic model. So in this Rutherford atomic model, there are another two subtopics are there, that is here in this Rutherford another two subtopics are radius of closest approach, radius of closest approach. And one more thing is impact parameter, we'll discuss later. So radius of closest approach. Here just now we have discussed, here there is a gold foil atom is there, now around this nucleus electrons are rotating. Here alpha particles are coming with some particular velocity, right? It has some particular kinetic velocity and it has some particular kinetic energy. So alpha particle is coming with some kinetic energy. Now, so it has this is a gold foil nucleus, it has a positive nature. This alpha particle also has a positive nature. So this positive and this positive is there is a repulsive force acts between the gold foil and alpha particle. So this gold foil alpha particle come here at this position. So the total kinetic energy of the alpha particle and this is converted into the potential energy. This total kinetic energy of alpha particle is converted into the potential energy, because at this position, so it is repelled more. Nucleus is repelled more because it has a positive charge and ఇది కూడా positive charge ఉంటుంది, ఇది కూడా positive charge ఉంటుంది కాబట్టి ఆల్ఫా పార్టికల్ కొంత కైనెటిక్ ఎనర్జీ సైడ్ మూవ్ అవుతుంది, రైట్. సో ఇది ఏం చేస్తుందంటే న్యూక్లియస్ గోల్డ్ ఫాయిల్ న్యూక్లియస్ ఏం చేస్తుంది, రిపల్ చేస్తుంది. రిపల్ చేసినప్పుడు దీని దగ్గరకు వచ్చేసినప్పుడు స్పీడ్ తగ్గిపోతుంది, బికాజ్ ఇట్ ఈస్ రిపల్లింగ్ ఇచ్చేది. దీని స్పీడ్ తగ్గిపోతుంది. ఒక పర్టికులర్ పొజిషన్ వచ్చిన తర్వాత దీని స్పీడ్ కంప్లీట్ గా జీరో అవుతుంది, లేకపోతే ఇట్ విల్ కమ్ బ్యాక్. రిపల్సివ్ పవర్ ఎక్కువైతే ఇట్ విల్ కమ్ బ్యాక్. Alpha particle is come back, right? So this distance, whatever the distance from nucleus to the alpha particle, this is called the name of radius of closest approach. Radius of closest approach. Once again, ఇది important. రేడియస్ ఆఫ్ క్లోజెస్ట్ అప్రోచ్ అంటే ఇక్కడ మనకి గోల్డ్ కాయిల్ ఉంటుంది, దీని చుట్టూ ఎలక్ట్రాన్స్ రొటేట్ అవుతాయి, గోల్డ్ కాయిల్ యాటమ్ అనేది ఎలక్ట్రాన్స్ రొటేట్ అవుతాయి. ఇక్కడ నుంచి మనకి ఆల్ఫా పార్టికల్ వస్తుంది విచ్ హాస్ సమ్ పర్టికులర్ వెలాసిటీ కాబట్టి దీనికి కైనెటిక్ ఎనర్జీ ఉంటుంది. కైనెటిక్ ఎనర్జీ ఉన్నప్పుడు ఇది ఇక్కడికి వచ్చేస్తుంది. ఆల్ఫా పార్టికల్ హ్యాస్ ఎ పాజిటివ్ చార్జ్ అండ్ దిస్ గోల్డ్ కాయిల్ న్యూక్లియస్ ఆల్సో హ్యాస్ ఎ పాజిటివ్ చార్జ్. సో ఈ పాజిటివ్ చార్జ్ దీన్ని ఏం చేస్తుంది, రిపల్ చేస్తుంది. రిపల్ చేసినప్పుడు ఇక్కడ దగ్గరకు వచ్చేసిన తర్వాత దీని కైనెటిక్ ఎనర్జీ ఏదైతే కైనెటిక్ ఎనర్జీ ఉందో కైనెటిక్ ఎనర్జీ మొత్తం కూడా ఇది రిపల్ చేస్తుంది కాబట్టి కైనెటిక్ ఎనర్జీ తగ్గిపోతుంటుంది. ఒక పర్టికులర్ పొజిషన్కి వచ్చిన తర్వాత కైనెటిక్ ఎనర్జీ కంప్లీట్గా జీరో అవుతుంది, లేకపోతే కంప్లీట్గా వేరే ఎనర్జీ కన్వర్ట్ అయిపోతుంది, పొటెన్షియల్ ఎనర్జీ కన్వర్ట్ అయిపోతుంది. సో ఈ డిస్టెన్స్ ఏమంటే ఏదైతే డిస్టెన్స్ ఉందో ఈ డిస్టెన్స్ ఏమంటే ఇక్కడి నుంచి డిస్టెన్స్ ఏమంటే రేడియస్ ఆఫ్ క్లోజెస్ట్ అప్రోచ్, రేడియస్ ఆఫ్ క్లోజెస్ట్ అప్రోచ్, రైట్? So the least distance between the alpha particle and nucleus of the gold coil is nothing but a radius of the closest approach. Here this is the nucleus. Here alpha particle coming towards the nucleus with some velocity which has a kinetic energy. Kinetic energy how much? 1/2 mv square. This total kinetic energy is converted to the potential energy. So because it repels each other and it come back. The potential energy ఏంటంటే potential energy ఫార్ములా ఉంటుంది మనకి ఏంటంటే it will come in the electrostatics potential energy formula 1/4πε0 into q1 q2 by r. That is the formula. Here 1/4πε0 into 1/4πε0 into ZE అంటే ఆల్ఫా పార్టికల్ అండ్ ఆల్సో ZE బై R. R అంటే R నాట్. ఇక్కడ ఆల్ఫా పార్టికల్ ఉందా, ఆల్ఫా పార్టికల్కి మనకి ఎన్ని ఎలక్ట్రాన్స్ ఉంటాయి అంటే 2 ఎలక్ట్రాన్స్ ఉంటాయి. 2 ఎలక్ట్రాన్స్ ఉంటాయి కాబట్టి 2e రాశారు. Here this gold coil nucleus atomic number. This is the potential energy 1/4πε0 into 2e into ZE by R naught. And so this is the kinetic energy. Whenever this kinetic energy and potential energy are equal, the kinetic energy and potential energy are equal, then that alpha particle come back into the return into the opposite direction, right? So this distance is called radius of closest approach. Now here potential energy should be equal to the kinetic energy. Now one more point I need to explain here, that is if alpha particle energy is more, the kinetic energy of the alpha particle is more, then this radius of closest approach is less. ఎందుకంటే ఆల్ఫా పార్టికల్ యొక్క ఎనర్జీ ఎక్కువ ఉందనుకోండి, ఎక్కువ ఉంటే ఇది ఇంకా దగ్గరకు వస్తుంది, దగ్గరకు వచ్చినప్పుడు రేడియస్ ఆఫ్ క్లోజెస్ట్ అప్రోచ్ అనేది తగ్గిపోతుంది, right? So if alpha particle energy is less, this radius of closest approach is more. That is here potential energy is equal to the kinetic energy. Potential energy is 1/4πε0 into 2e into ZE by R is equal to kinetic energy E. Then if we rearrange this one, R is direct inversely proportional to E. R is inversely proportional to E, or R naught is inversely proportional to E. If energy of the alpha particle is more, then radius of closest approach is less. If energy of alpha particle is less, radius of closest approach is more. Or we can write like this also, R is inversely proportional to V square. Now R1 by R2 is equal to E2 by E1. E is the energy of the alpha particle, remember it. Now R1 by R2 is equal to V2 square by V1 square. If you compare two alpha particles, which has some particular energy E1 and another one is E2. Then he will give this alpha particle, second alpha particle energy, first alpha particle energy, and first alpha particle radius of closest approach. Just find out the R2 by using this equation, this formula. And here also same, V1 will give, V2 will give, R1 will give. You can find out the R2. So finally, radius of closest approach is inversely proportional to the energy of the electron, energy of the alpha particle. So this is about the radius of closest approach. And one more thing, and another one is impact parameter. Another one is impact parameter. Impact parameter. Impact parameter, we will indicate this impact parameter with B. What is impact parameter? Impact parameter in the sense, here if you observe, if you observe here, this is the target nucleus. Target nucleus in the sense, nucleus of the center of the gold foil atom. If you take one gold foil atom, this is the target nucleus, center of the nucleus. Now from here, alpha particles are coming here. Alpha particles నుంచి వస్తుంది. ఏదైతే if you observe, చూడండి, నేను నెంబరింగ్ ఇస్తాను ఇక్కడ, నెంబరింగ్ ఇస్తాను. 1 1 2 3 4 1 2 3 4 థర్డ్ ఆల్ఫా పార్టికల్ చూడండి, ఇక్కడి నుంచి వచ్చేసిన తర్వాత ఇట్ డివైడ్ అయింది. ఈ ఆల్ఫా పార్టికల్ ఇది వెనక్కి వచ్చేస్తుంది, బికాస్ ఇట్ ఈస్ మూవింగ్ టువర్డ్స్ ద సెంటర్ ఆఫ్ ది న్యూక్లియస్. అండ్ ఈ ఆల్ఫా పార్టికల్ డీవియేషన్ తక్కువ ఉంది, ఈ యాంగిల్ డీవియేషన్ యాంగిల్ ఉంది, రైట్. ఇది అసలు తక్కువ డివైడ్ అయిపోయింది, బికాస్ సెంటర్ నుంచి డిస్టెన్స్ ఎక్కువ ఉంది కాబట్టి. నౌ what is impact parameter? Now impact parameter is this is the center of the nucleus. It's the center of the nucleus. Now alpha particle initial direction ఉంది, initial direction ఉంది. యాక్చువల్ గా అక్కడ న్యూక్లియస్ లేకపోతే ఈ డైరెక్షన్ లో పోవాలి, కానీ న్యూక్లియస్ ఉంది కాబట్టి డివైడ్ అయింది. ఈ సెంటర్ నుంచి ఇనిషియల్ గా అది ఏదైతే డైరెక్షన్ ఉందో, ఆల్ఫా పార్టికల్ డైరెక్షన్ ఉందో, ఆ డిస్టెన్స్ ఏమిటంటే, ఈ డిస్టెన్స్ ఏమిటంటే చూడండి, ఈ సెంటర్ నుంచి ఇనిషియల్ గా ఏదైతే మీకు ఆల్ఫా పార్టికల్ డైరెక్షన్ ఉందో ఆ డిస్టెన్స్ ఏమిటంటే బి, ఇంపాక్ట్ పారామీటర్. ఇంపాక్ట్ పారామీటర్. హియర్ ఇఫ్ యు అబ్జర్వ్ దిస్ వన్, దీన్ని చూడండి, ఇది ఈ డైరెక్షన్ లో పోవాలి, ఇది సెంటర్. ఇక్కడ ఇంపాక్ట్ పారామీటర్ తక్కువ ఉంది, దీనికి ఇంపాక్ట్ పారామీటర్ ఇక్కడ నుంచి పర్పెండిక్యులర్ డైరెక్షన్, పర్పెండిక్యులర్ డిస్టెన్స్ అనేది ఎక్కువ ఉంది. ఇక్కడ చూసి దీన్ని చూడండి, యాక్చువల్గా ఈ డైరెక్షన్ వెళ్ళాలి, ఇది మనకి సెంటర్, ఇది సెంటర్, ఈ డిస్టెన్స్ ఎక్కువ ఉంది. ఇంకా చూస్తే ఇక్కడ ఈ డిస్టెన్స్ కూడా ఇంకా ఎక్కువ ఉంది. సో నౌ we can say that the perpendicular distance of the from center of the nucleus or center of the gold foil to the initial velocity vector, initial direction of the ఇక్కడ నుంచి distance అంటే impact parameter. Now impact parameter కి ఎనర్జీ కి ఎలా ఉంటుంది, ఇంపాక్ట్ పారామీటర్ కి యాంగిల్, డీవియేషన్ యాంగిల్ ఎలా ఉంటుంది చూడండి. వీటికి దగ్గర ఉన్న వాటికి దీనికి డీవియేషన్ యాంగిల్ ఎక్కువ, దీని డీవియేషన్ యాంగిల్ తక్కువ. అంటే ఇక్కడ ఇంపాక్ట్ పారామీటర్ ఎక్కువ ఉంది. ఇంపాక్ట్ పారామీటర్ ఎక్కువ ఉంటే డీవియేషన్ యాంగిల్ తక్కువ ఉంది. ఇది డీవియేషన్ యాంగిల్ తక్కువ ఉంది. ఇక్కడ చూడండి impact parameter. Now here impact parameter is for this one. Impact parameter is less, deviation is more. Ikkada impact parameter is very less, so deviation is more. So అంటే ఏవైతే ఆల్ఫా పార్టికల్స్ దగ్గరకు వస్తున్నాయో దాని దగ్గరకు వస్తుంది న్యూక్లియస్ దగ్గరకు వస్తున్నాయో సో ఆల్ఫా పార్టికల్స్ డీవియేషన్ అనేది ఎక్కువ ఉంటుంది, ఇంపాక్ట్ పారామీటర్ అనేది తక్కువ ఉంటుంది. సో దీనికి ఇంపాక్ట్ పారామీటర్ ఎక్కువ, డీవియేషన్ తక్కువ. దీనికి కూడా ఇంపాక్ట్ పారామీటర్ ఎక్కువ, డీవియేషన్ తక్కువ. ఇవి చూస్తే ఇంపాక్ట్ పారామీటర్ తక్కువ, డీవియేషన్ ఎక్కువ. సో B is more and theta is less. So this is about the impact parameter and radius of closest approach. So now this is about the Rutherford atomic model. Now I will give one brief explanation about the Rutherford atomic model once again. Rutherford atomic model. In Rutherford atomic model, they have given total positively charged and total mass is concentrated at the nucleus, and all the electrons are revolving around the nucleus. So total atom is empty. Most of the atom is empty. Total mass is concentrated at the nucleus. This statement, so it has proven by the one experiment that is called famous Rutherford alpha scattering. That Rutherford alpha scattering, in that Rutherford alpha scattering, there is a gold foil is there. There is a polonium atom is there, and screen is there. Gold foil screen is there. Another one is screen, zinc sulfate screen is there. Then alpha particles emitted from the polonium radioactive element. Then some of the alpha particles are undeviated. Most of the alpha particles, 99% of the alpha particles are undeviated. It is moved and incident on the zinc sulfate screen. But 2% or 3% of the alpha particles are deviated. Some of the alpha particles are come backward, and some of the alpha particles are deviated some particular angle. Why most of the alpha particles are not deviated, and why some of the alpha particles are deviated? Because whatever the alpha particles which is passes through the towards the nucleus of the gold foil, it is deviated. Because there is a electrostatic force between the nucleus and alpha particles. Due to this repulsive force, there is some deviation happening. But most of the atoms, most of the alpha particles are does not deviated, because those alpha particles are passes through the electrons around the nucleus. The electron doesn't have that much of energy, so easily it is passes through the electrons. So that is the experiment. Now, how many number of alpha particles are deviated, and how many number of alpha particles are undeviated, and how many what is the alpha particles distance of closest approach, and what is impact parameter? Now, already we have discussed about this one. This is the number of alpha particles deviated formula. Now, number of alpha particles deviated is directly proportional to T and directly proportional to Z square, and inversely proportional to the E square. E is the energy of the alpha particle. If energy is more, it is undeviated, then it's undeviated, then deviation, number of deviation alpha particles are less. And E is equal 1 by m square. So with respect to velocity, n theta is inversely proportional to p power 4. One more thing is, number of alpha particles are inversely proportional to sin power 4 theta by 2. It is also equal to the n theta is directly proportional to the cosecant power 4 theta by 2, because sin power 4 theta by 2 is equal to 1 by 2 cosecant power 2. Now n1 by n2 is equal to this one, or n1 by n2 is equal to e2 square by e1 square. Already we have discussed. Then next, after this number of alpha particles are scattered, this is the radius of closest approach. Whenever alpha particles comes towards this direction, this nucleus is repulsed. It has some particular kinetic energy. Nucleus has potential energy. So at a particular moment, at a particular distance from the center, so this nucleus completely repelled the alpha particle. That's why it come back. 180 degrees. So this total at this position, the kinetic energy should be equal to the potential energy. This distance is called radius of closest approach. Thus, the distance. What is the relation between the radius of closest approach and energy? If energy of the alpha particle is more, it comes close towards the nucleus. Then radius of closest approach is less. R is inversely proportional to E. R is inversely proportional to E. So in the mundu n theta is inversely proportional to E square. But here R is inversely proportional to E. R naught, you can say this. And inversely proportional to V. It is inversely proportional to V power 4. Now, this is about radius of curvature, radius of closest approach. Next one is impact parameter. So whenever alpha particle comes towards the nucleus, if you draw one line, the alpha particles are coming towards like this. Due to this nucleus, it is coming deviated. If you draw one line from the nucleus, this is called impact parameter. Right. For this alpha particle, impact parameter is less, deviation is more. If alpha particles comes to which is around the region of the alpha nucleus, then వాటికి ఇంపాక్ట్ పారామీటర్ అనేది తక్కువ ఉంటుంది, డీవియేషన్ అనేది ఎక్కువ ఉంటుంది. ఒకవేళ ఇక్కడ ఏమనుకోండి, ఈ ఆల్ఫా పార్టికల్ కి ఇంపాక్ట్ పారామీటర్ ఇస్ మోర్ అండ్ డీవియేషన్ ఇస్ లెస్. So this is about the impact parameter and radius of closest approach and number of alpha particles scattering. This is about Rutherford model. So in next video we will discuss about the what are the success, what are the merits, and what are the and failures of Rutherford atomic model. We will discuss in the next video. Thank you.